Hi everybody. So this is the third lesson about quadratics. The first lesson we talked about standard form. The next lesson we talked about vertex form. Today we're going to talk about our last form, which is intercept form. So remember that quadratics can be written in three different forms. Same function, just three different ways to write it. Okay? So we're going to talk about the same things that we talked about the last 2 days, where we can graph a quadratic function now in intercept form, but where we can identify all key information, meaning extremums, vertex, axis of symmetry, and intercepts, whether it be x or y. Okay? Alright, actually before we start this, I thought I would go over, just to make sure we're okay, a question from the homework. So if you already know how to do this, you can kind of fast forward a little bit, otherwise this might be good review for you. Okay? So if we were doing this function right here, remember opposite of this value, and then this value gives you a vertex, so opposite would give me a -5 and a -3. Because this is a positive a value, I know the function opens up, which means that the extremum is a minimum, and it would be min at the height of -3. The axis of symmetry would be x equals -5, since it's got to go through that x value. Remember, we're pulling the x. The y-intercept I find, I always start by saying 0, comma, that way I know I'm substituting 0 into my function. So I'm going to say 3 times 0 plus 5 squared minus 3. Okay, this is 5 squared, which is 25. And then 25 times, well, I'll write it out. So 3 times 25 minus 3. So this would give me 75 minus 3 is 72. So there's my y-intercept. It won't show up on our graph, but it does exist. Okay. The x-intercepts I need to find by graphing. So I have -5, -3 that I would plot. So -5, -3. Make sure you plot it in the right place. Be careful that we go the right direction. The only thing I care about now that I'm graphing is 3x squared, since that's my a value. It will always be x squared since we're talking about a quadratic function, and that's what creates the u-shaped graph. Okay, so I'm going to move right, square, and multiply by 3. So I move right 1, squared is 1, but times 3 means I move up 3. There's one of my x-intercepts. If I move right 2, 2 squared is 4. 4 times 3 is 12. So if I move 4, 9, 10, 11, 12. Okay, and then I can find my symmetrical points. This one doesn't have very many points that lie in the graph. Oops. You will notice that there won't be very many points on the graph when a is something like 2, 3, 4, but when a is something like 1/2, -1/2, something like that, there will be a lot more points that fall on the graph. Okay. Don't forget to label your intercepts. It would be at -6, 0, and at -4, 0. Make sure you write that in the right order. Sometimes we flip those values and then they become y-intercepts. Okay? Alright, so today's notes is talking about intercept form. On the top of your sheet, let's write down the two that we know. This is standard form, where we have ax squared plus bx plus c. This is vertex form, where we have a times the quantity of x minus h squared plus k. Okay, notice in each of these we have an x that's being squared. This one x is squared, and this one the quantity of x minus h is squared, which creates that u-shaped graph. I notice they have different variables, but the one thing that they have in common is the a value, because that's what shapes my graph up, down, and how skinny it is. Alright? Intercept form of a quadratic, so the last form is y equals a, notice again there's an a, x minus p, and x minus q. Okay? The x-intercepts are these p and q values, so it'll be whatever p is, comma 0, and whatever q is, comma 0. And notice it's p and then 0, and then q and then 0, because an x-intercept has 0 as y. Alright, similarities from yesterday's. Notice that it's x minus p, and up here it's x minus h. That means whatever is in these parentheses is opposite, just like over here. Okay? Alright, so let's plot a point here. So let's say that we plotted a point here, and let's say this is at 8, 0. And let's plot a point over, oops, sorry, -8, 0. And let's say I plotted a point over here, and I called this 2, 0. Okay, let's say that I made my function go down, something like this. My axis of symmetry would be right through the middle of this, so right there. The way that I can find this, notice that from here to my axis of symmetry and from here to my axis of symmetry should be the same distance. So this distance should be the same since it's symmetrical. So what that means is my vertex that lies right here must be directly between -8 and 2. And something that's directly between means that I'm averaging them. So that means that I would do -8 plus 2, and I would divide it by 2, since there's two numbers there, which would mean that this is -6, so that would mean -3. So this would be at the value of -3 comma something. I don't know what the heck is. Okay, the important thing is that the vertex is directly in the middle of those x-intercepts and can be found using the formula x equals, notice I just added those values, so I add my p and my q, and then I divide by 2. Okay, and then once I know x, I can find y by substituting. Okay, so pretty similar to standard form, except instead of opposite of b over 2a, it's p plus q divided by 2. So now you have two formulas you have to memorize. Okay, so we'll go through example 1 and 2 and use that new formula. It says given the function f of x equals, notice it's written as a quantity times a quantity. That's how we know that it's intercept form. Okay, I'm going to scroll back up. Notice up here we have ax squared plus bx plus c. Here we have a quantity that's being squared, so that's vertex form. When I have two quantities being multiplied by each other, that's what makes it intercept form. Okay, my p-value, my p-value is the opposite of -4, which is 4, and opposite of +2, which is -2. Okay, notice again that they're both in the parentheses, so just like yesterday, opposite values. My a value, there's nothing out there, so it's a +1. So since it's positive, my function will open up. Since it opens up, that means that this has a minimum. So I'm going to say min at, and then I don't know what it is, so I'm going to go find it. With the other two functions, we started with vertex. We're actually going to start with the intercepts this time because we were told them. Since it's called intercept form, we get our intercepts, specifically our x. So if our p is 4, then one of our x-intercepts would be 4, 0, and then the other one would be -2, 0. Okay, so this is actually our first step now, which is different than the other two. Once I know my intercepts, then I want to go find my vertex. So notice I'm going right back to find your vertex, because then that will give me that right there as well as my x-axis, or my axis of symmetry. Okay, so I'm going to write this down so we know where it's coming from. I'm going to use p plus q divided by 2. Okay, so that means I'm going to say x equals 4 plus -2 divided by 2, which is 2 divided by 2, which is 1. So part of my vertex right here is 1. I can find my y by substituting in. Go up here so I see my function. So, oh my goodness. Alright, so instead of x minus 4, it's going to be 1 minus 4. And then instead of x plus 2, it's going to be 1 plus 2. So I have two places that I'm substituting in. This gives me -3. And this gives me +3. Okay, I would make sure you put parentheses so you don't accidentally try to add them. And that gives me -9. And that would be my vertex. Okay, from my vertex, now I know my extremum, so that's the third step. So that would be a minimum at -9. It also gives me, I'm going to make this also step 3 since it doesn't matter which one comes first. My axis of symmetry would be x equals 1. Okay. Once I have those, the very last thing that I can do is find my y-intercept by substituting in a 0. Okay, so I always start by saying 0 comma, that way I know to substitute. So when I substitute into my function, instead of 0 minus 4, or sorry, x minus 4, it'll be 0 minus 4, and 0 plus 2, which gives me -4 times 2, which is -8. So that would be my y-intercept. Okay, I'm going to plot all 4 of these coordinates. I have a vertex, 2 x-intercepts, and a y-intercept. So I'm going to start with 1, -9, which is here, so that's my vertex. I also have 4, 0, and I also have -2, 0. and I know my y-intercept is at 0, -8. Okay, so there's a lot of ways that I can check to make sure that vertex is right. My a value is 1, so this is what I'm thinking as I create my function. Okay, so I move right 1, 1 squared is 1, so that makes sense. If I move right 2, 2 squared is 4. 1, 2, 3, so here's 4. And then if I move right 3, 1, 2, 3, 3 squared is 9, which puts me right here, so I know that I'm good. Now I'm going to move right 4, 1, 2, 3, 4. 4 squared is 16. So here's 9, 10, 11, 12, 13, 14, 15. So I'd be up here. Okay, now I can fill in with my symmetrical points. Here. Here. Okay, make sure that we have all coordinates that lie in the graph. Make sure we connect with a U-shaped graph. And make sure that you have arrows on both ends. Okay, and that would be your function. Alright, if you need to pause or go back and re-listen to anything, make sure you do. I'm just going to double check my key features and make sure that I actually have everything filled out. Okay, we started with the x-intercept, we used it to find the vertex, we used the vertex to find extremum and axis of symmetry, and then I found my y-intercept, which you can do at any point by substituting in 0. Alright, let's try again. This would be a good one that if you wanted to try some of it on your own and then pause it and kind of listen, where you get stuck, you could. That'd be a good idea. Otherwise, you can listen to me go through it. Alright. Opposite of 6 is -6. Opposite of -2 is +2. And my a value is -1/2. Because this has a negative a value, it's going to open down, which means it has a maximum. So I'm going to say max at. Since it's in intercept form, it's giving me my intercepts. So I'm going to start with that key feature. So -6 means that this would be -6, 0, and this would be 2, 0. Okay, make sure we're writing them as coordinates, but this is my first step. I'm going to use those two intercepts to find my vertex. Okay, so I'm going to say x equals my p value plus my q value divided by 2, which is -4/2, which is -2. Okay, so there's my x value. I'm going to say y equals, so I know I'm finding y. I'm going to substitute back in. Alright, so this is going to be -1/2, -2 plus 6, and -2 minus 2. Alright, -1/2 times 4 times -4. And you can perform this in a couple ways. I'm going to take half of 4. So this gives me -2 times -4, which I'm writing out just so I don't lose the negatives, which gives me 8. I could also do 4 times 4 is -16. Half of that is 8. So there's my 8. Okay, because of that, I can now identify my extremum and my axis of symmetry. My max would be at a height of 8, and my axis of symmetry is at x equals -2. Make sure we're writing everything in the correct form. My y-intercept I'm going to find by substituting in 0. So this will be -1/2 times 0 plus 6 times 0 minus 2, 0. Okay, so that's -1/2 times 6 times -2. This gives me 12. Half of 12 is 6. Notice the negatives cancel out. So my y-intercept would be at 0, 6. Okay, I'm gonna go plot all 4 of those points just to make sure everything lines up. So I have 0, 6 is my y-intercept, -6, 0 is an x-intercept, and so is 2, 0. My vertex is at -2, 8. Let's see, -2, 8. My a value, what was my e value? -1/2. So what I want to use to graph is going to be -1/2, -1/2 x squared, which means I will move right, square, and multiply by -1/2. Okay, so this is my vertex right here. If I move right 1, 1 squared is 1, half of that means I move down a half. If I move right 2, 2 squared is 4, half of that means I move down 2. If I move right 1, 2, 3, 3 squared is 9. Half of that is 4.5. So 1, 2, 3, 4.5. 1, 2, 3, 4. 4 squared is 16. Half of that is 8, which makes sense because then there's 8. I go back up here. 1, 2, 3, 4, 5. 5 squared is 25. Half of that's 12.5. So here's 8, 9, 10, 11, 12.5, and I probably have another one that fits. So 1, 2, 3, 4, 5, 6. 6 squared is 36. Half of that's 18. So there's 8. There's 10 more. Okay, find my symmetrical points. Okay, take your time finding your symmetrical points. Make sure, again, you find all. Hopefully you can connect better than I can on the computer. And then this is what your function would look like. Okay, make sure you have arrows, make sure you have all coordinates, make sure you connect the coordinates. Sometimes I see you guys not connect points. Okay, double check, make sure that you've identified all your key features, which we have. Alright, so intercept form is very similar to the other two forms, except that we start with x-intercept, and then we use that to find vertex. And then again, we go from vertex to extremum and axis of symmetry, and y-intercept to last. Alright, go ahead and flip over. Alright, example 3 says a quadratic function has a vertex at -4, -5, and has an a value of 1/2. So plot a point at -4, -5, and create a quadratic function that has an a value of 1/2. So that means you would be doing 1/2 x squared. Okay, go ahead and pause and then see if you can get the same answer as me. Alright, so check your answer, but this is what you should have gotten. Make sure you have all of those coordinates. Alright, down below this example is another one that's pretty similar, except that the vertex and a value have changed. Since it's an a value of -3, you will be graphing with this. So go ahead and see if you can do that. Just to note up here, it's okay that we didn't hit the x-axis since I didn't explicitly ask for the x-intercepts. Alright, so go ahead and try this one. Alright, assuming you're checking your answer, I thought I'd go through this one since it's not going to have very many coordinates. Make sure that you're up here at 210. If I go right 1 and I square it, I get 1 times -3 puts me down 3. So those would be my 2 points. If I go right 2, 2 squared is 4, times -3 is -12. So 10, 11, 12. And my symmetrical point will be here. If I go right 3, 3 squared is 9, times -3 is -27, which won't fit because there's only 20 lines here. Okay, so not very many points here. Oops. Sorry, can't do a very good job of connecting this, but you should look like that. Alright, let's try 2 other examples. In number 4, it says, write the quadratic function f of x equals. So this is in intercept form. Okay, I'm just going to write intercept here. And we want to convert it into standard form. So if I gave you this, imagine that before this unit I gave you this, I would expect that you wouldn't really know what to do other than to perform order of operations and simplify. That's all you need to do. You can either distribute the -3. I think it's easier to do this, so we can take that shortcut. Okay, meaning I can say -3, x times x is x squared. If I add these two numbers, I get -3x. If I multiply those two numbers, I get -10, so that's what you just did in the last test. I can distribute those, and then I get -3x squared plus 9x plus 30, and look at that, it's in the form of ax squared plus bx plus c. Okay, so by simplifying, we put the intercept form into standard form. Since it was f of x to start with, I'm going to say f of x equals, and this. So same function, 2 different forms. Okay, so just simplify. Number 5, we want to find the vertex of the quadratic function. Okay, go ahead and pause this. This is a good one for you to try on your own because we just did it twice in the first 2 examples on the other page. Okay, in order to find the vertex in intercept form, you need to make sure that you do x equals p plus q divided by 2. Before you start, you want to make sure you identify your p and your q. So p is +4 and q is -6. Remember, opposite values. Okay, so again, this would be a good place for you to pause and try on your own. Okay. Assuming you're checking your answer, you would say 4 plus negative 6 divided by 2, which gives you negative 1. Alright, we want to find our y by substituting in. So this gives us 2 times negative 5 times 5. Let's see, this gives us negative 10, so negative 50. So that means find the vertex of the quadratic function. We would say that our, oops, don't say y equals. We would say that our vertex is negative 1, comma 50. Okay, and this is what the question was asking for. But if I asked you to write the function in vertex form, you actually could pretty easily. So let's say that I write this down. So go ahead and write this down. This is my vertex form, which needs an a value, an h, and a k. Well, I already know h and k, and I also already know a because it's right here. So I could actually rewrite this pretty easily, and I could say my a is 2. If I want that to look like a negative 1, I have to write plus 1 squared. And if I want that to be a 50, I have to write plus 50. So I just converted intercept into vertex form. Alright, last couple of things. We want to organize what we're doing here. Okay, standard form is written as y equals ax squared plus bx plus c. Vertex is a times x minus h squared plus k, so one quantity being squared. Intercept is y equals a times x minus p times x minus q. So two quantities being multiplied by each other. Notice minus, minus, minus. Okay. What should you do first? So if you're trying to find key features and you're in standard form, find the vertex first. And you will do that by doing x equals opposite of b over 2a. If you are in vertex form, find vertex first, which is actually very easy because it's just pulling out the h and the k value, and I'm going to make a note here that says opposite, meaning your h value. Okay. When you are in intercept form, the first thing you want to find is your, you want to find your x-intercepts, not your y. So x-intercepts, which are just your p value, comma 0, and your q value, comma 0. And I'm going to again make a note here that these are opposite. So whatever it looks like, p and q are opposite. Alright, so that should give you an idea. From your x-intercepts, then you can use that form x equals p plus q divided by 2 to find your vertex. Alright, so this concludes this lesson. Your homework is worksheet number 4, which you can grab from the sub. And then go ahead and work on your homework, and I will be back tomorrow. Thank you.